Good day, viewers. Before setting up your inverter, these are some basic terminologies that you must know before you size your panel, your battery, or your inverter. So today I'm going to be breaking it down for you. Number one is your inverter efficiency. If you have been following me, there is this function that your inverter does. Let's assume this is your inverter. And the type of current coming from your panel, your battery, is direct current, is a DC current. While the type of current that you use with your appliances at home are alternating current, AC current. So what inverter does is that once the DC current is entering into it, before you can make use of it at home, it's going to convert it for you into an alternating current. So when it's doing this work, some energy is lost. Let's assume your inverter is 1000 watt inverter. So you will not be able to make use of the maximum 1000 watts from this inverter. Some of the energy is going to be lost because of this conversion. So this is called the inverter efficiency, and it's mostly calculated as 90%. So if you buy a 1000 watt inverter, what you are going to be making use of maximum is 900 watts, which is 90%. So also if you buy a 2000 watt inverter, what you are going to be making use of is going to be 1800 watts because of this inverter efficiency. So before you size your inverter, you must put up your inverter efficiency into play so that you will not undersize it. Number two, we are going to be talking about the resistive and inductive load. But before you can understand that, these two terms, the operating power and the running power, you need to understand them. So what are operating powers? Let's say your iron is rated 200 watts. This is the operating power of the iron. It means as you are using the iron will be consuming 200 watts of energy. While your running power, let's take your fan for example. Your fan is rated 30 watts. Before it can start working, it has to start with a running power. The running power, due to such, sometimes they take about times 2, times 3. So for your fan to start working, the running power is going to be like times 3 of the operating power, which is 90 watts. So some of your appliances, their running power is the same as their operating power, and these appliances are called the resistive loads. The appliances that their running power, the rated power that they have, is what they are going to be using to operate. They will start with it and end with it. Like your iron, it starts with 100 watts. No matter how long you use them, it will be using the 100 watts. Why some loads that has coils, that has compressors, like your freezer, your fan, they are inductive loads. These are loads that before you use them, they will start with an operating power. The operating power that is built with them is 100 watts. Before they start running, they will use times 3 of that operating power, which is like 300 watts. So before you size your panel, your battery, you have to take your resistive loads and inductive loads into consideration. So these are some of the examples of your resistive loads and your inductive loads. A simpler way to get this is that any devices that use coil, rotor, a compressor, like freezer, fridge, pumping machine, anything that rolls, shake, those are your inductive loads. They have a surge of about 2 times to 7 times of their operating power. While resistive loads, these are some of the examples of your resistive loads. They use the same operating power as their running power. Number 3, we have your temperature efficiency or temperature compensation factor. Because of the load your battery is carrying, some energy are lost because as the current is coming in, some current is being pulled out. So temperature efficiency is like the amount of energy lost by your battery working. It's rated sometimes about 90%. So let's say you have 1000 watts of battery, the only 10% will be lost due to temperature efficiency. Number 4, we have DOD and state of charge, SOC. So let's say this is your battery bank. This is for tubular battery. Tubular battery has DOD of 50%, while your lithium battery, tubular battery, they all this lead acid battery, tubular battery is one of them. So your lithium battery is around 80 to 90%. Let's use 90%. So this is your battery bank. As stipulated, your tubular battery, they only give you depth of discharge. So it means when you are using your battery, you can only use, for efficiency's sake, you can only use 50% of it. This is not advisable to use more than 50% so that you will not run out with the efficiency of the battery. So this is your DOD, which is 50%. The remaining part is called your state of charge. Amount of current that is remaining in your battery is your state of charge, SOC. So your SOC is about also 50%. So you cannot discharge your battery more than 50% if you are using a tubular battery. Let's take for example, your tubular battery is 1000 watts. The DOD that you are supposed to be using with this your battery is just 500 watts, which means every day if you are depleting your battery, you must not deplete it more than 500 watts. While for lithium battery, it has higher DOD. It means you can deplete it up to 90%. The DOD is 90%, and the state of charge is 10%. So it means, let's say you have the same 1000 watts battery, for a lithium battery, you can successfully use 900 watts out of it and leave the 10 watts. It's more advisable if you want to set up your solar, you should go for lithium battery because it has higher depth of discharge than your tubular battery. With my explanation, I believe you all understand all what you have been saying, from the inverter efficiency, resistive and inductive load, up to our DOD and SOC, that's the state of charge. So in my next video, I'm going to be taking the remaining four, that's the PPR, the peak, SH, inverter idle power consumption, and the day of autonomy. Follow me, subscribe to my channel so that you will not miss the next video. I will see you on the next one.